To start recording. All right, guys. So what we're going to be doing today is, well, first we'll start off with a little bit of a review. Hopefully you guys are getting your web assignments done. People are joining late. All right, so just a couple, so you had a couple seconds to look at the warm-up. So if we take a look here, slope-intercept form. So that's the one that's not very useful. Okay. Point slope form, this is the one that is really useful. This is the one that we want to get used to using. I'm going to write it in function notation. So it's going to be f of x minus y1 equals m times x minus x1 parentheses. And remember, right, this is your output, this is your slope. And the point x1, y1 is your slope. Really shouldn't do equal there, right? Okay, and then a circle, I think I ran out of time last time when we couldn't do that. Remember, a standard circle is just Pythagorean theorem. It's just x squared plus y squared equals r squared, where r is the radius. Okay, and then if you have a non-standard circle, it's x minus h quantity squared plus y minus k quantity squared equals r squared, where h, k is the center. And remember from transformations, and we're going to talk about this over the next week, that anytime a transformation is inside the function being squared, right, it's backwards. So when you see this minus, it really means opposite. So the center, the x value, is the opposite of this, right? So if this was x minus 2, this would be 2. If this was y minus 5, this would be 5. Okay, so that was just a quick warm-up for you guys, and go in there. So now it seems like most people are here. Happy Friday, everybody. We made it through the second week, or we're about to make it through the second week. Since 4th and 5th period are a day ahead of my other classes, I normally was going to do 1.4 and 1.5 today, but today I'm just going to be doing 1.4. So we're going to have a little bit more time with 1.4 than my other class. So please remember, guys, that you will have an assignment. It will be posted at the end of class. It will be due by next class. This is another reminder that your assignments are graded based on correctness. So you get 5 attempts. So make sure you guys are asking questions and not just using your 5 attempts and getting things wrong. Okay? As always, if you have a question, you can type it into chat, or you can turn on your mic and ask a question. Okay? This video is being recorded without your voice or your face, even if you turn your voice on or face on, because it doesn't record what I hear and it doesn't record what I see. It only records this and what I say. So I will be posting that hopefully by 3 o'clock onto YouTube. All right. So if there aren't any questions, I'm going to get started. So 1.4 and 1.5 are really about functions, right? And just remember, there's fun in functions. All right. And I hope you guys liked my my emoticons. Here, let's see if I can add another one. See there? Ooh, party time! It's Friday. All right, cool. So we're going to be talking about functions today. We do have a couple of things that we need to do. So remember, what is a function? Okay, so what is a function? So a function has inputs and outputs, okay? So an input, we normally called it x. It doesn't have to be x, right? So an input, we call this the, have to stop doing equal signs. We call this the independent variable. The reason why it's independent, think about time. Oops, I need to take off this this class thing. Sorry, I'm still getting used to this software. I haven't paid for it yet, so you'll see a ManyCam watermark. Hopefully I'll pay for that and we'll get rid of the ManyCam mark. Okay, so it's the independent variable. Think of time, right? Time is independent. It's always going forward. We have the output, y or f of x. That is the dependent variable. Okay. All right. Some things that other things we need to know. Domain. Right. Domain is the values that work for the input, and range is the values that work for the output. Okay, we're going to focus on domain today. We're going to focus on notation and how we write that and how we find domain and things like that. So super exciting, right? I can tell that you guys are super excited to be here on a Friday morning. That's a joke because I can't tell. So that was a joke. All right. What else do I want to talk about? Oh, the last thing is functions. Are one input has one output. Okay. Oops, I'm not on there. Oh, Grace, you're so excited. I'm so excited that you're excited. Oh my gosh. Wait. That deserves a okay, maybe that's not the right emoticon for that, but I feel like when Grace said so excited, that I feel like that was Grace's face. I just imagined in my head. That looks a little creepy. Yeah, maybe not. Maybe superhero. Grace is super excited. Yeah, now you're more excited. All right, so this is embarrassing for everyone. All right, so let's keep going. Okay, so that's what a function is. We're going to keep going on that. And again, guys, you should be reading these sections. So like read 1.4 on your own. I don't have time to go over everything. So make sure that we are going through and reading the sections. Yeah, no, Caitlin, I'm really, hey, it's Friday, guys. We gotta feel good, you know? And review is so boring, you know? Because it's review. It's like, I don't remember it, but it's still pretty boring. All right, evaluating a function. And hey guys, sorry, this one right here, this is really big, right? A function has one input has one output, right? So an example, ooh, my beautiful fake wood. Ooh, I know you're jelly. One input has one output, what do I still want to say? Oh, example, right? If I have y equals plus or minus the square root of x, this is not a function. Right? Because one input is going to have more than one output. Okay? And we'll talk about that a little bit more in a second. But that's how you can test it algebraically. You're just making sure for every input there's only one output. Okay? So not a function because it has two different outputs. All right. So where am I going to next? Okay, so make sure you can evaluate a function. Oops, there's an A here. Evaluate a function. So the reason why I'm talking about this, sorry, I'm not on here. The reason why I'm talking about this is we're using function notation. So let's say I have g of x equals negative x squared plus 4x plus 1. Okay, So again, using function notation. So I might want to find g of 2. Okay, it is really important, guys, that you know that this right here is your input. Okay, and notice what's it replacing? It's replacing x. So our next step is to replace all of the x's with 2. So we're going to have, now people always, they get lazy and they skip this step, but anytime you're plugging in for a variable, you have to put parentheses around it. So then we're going to go through and evaluate this. So I do order of operations. Right, when we evaluate, we go left to right, okay? Which is different than solving, right? When we're solving, we go backwards. So I'm going to do exponents first. So I'm going to have negative 4 plus 8 plus 1. So I'm going to have 5. It's okay if you skip writing down this as long as you have it down on the bottom. Okay, so hopefully that's not new news for anyone, but you know, I can be wrong, so you can tell me if it is and I need to spend more time on it. What might be new news for you is instead of putting a number in, right? No one ever said you can't put anything else, right? Like maybe I want to put a badger. Or maybe less cool, I just put an expression. So maybe I put c plus 2. Okay, now you might think, huh, that looks really confusing, but it's not confusing. It's not more confusing. You're still doing the same thing. It used to be g of x. So anywhere we have an x, I'm going to replace it with c plus 2. And even more important now that we put the parenthesis when we plug in. So let's go ahead and do this. We're going to get g of c plus 2 equals negative c, the quantity of c plus 2 squared, plus 4 times the quantity of c plus 2 plus 1. Okay? So we're not going to get a number here. We're going to get an equation. So taking a look at this, I need to square this. So that's going to be c squared plus 4c plus 4 plus 4c plus 8 plus 1. If you're not being able to do perfect squares super quick, just remember the old school way. So do you see how I got the c squared? The 2c and 2c is 4c, and the 4 is 4. Okay. It's really going to benefit you if you learn shortcuts. So I learned a shortcut. I just memorized this is what it is. The more shortcuts you have, the faster and more enjoyable math is going to be, right? And you can focus more on getting the right emoji. All right. So now we want to, so I'm going to distribute. And then I'm going to combine terms. So I got a negative 4c and a 4c. And then, so what am I going to be left with? Negative c squared, and I think it's 5. Okay. So make sure you guys can do that. This is why function notation is so superior to whatever that stupid notation is called that we taught you in Algebra 1. All right. I'm just drinking some tea. I love tea. All right. Cool. So, and then one last thing. I want to do another one. So I don't know how I'm going to do this lesson in my third period class. It's just so much more relaxed. We're only doing 1.4 today. So what happens if you have a piecewise function? Yeah, my piecewise function brackets suck. You're just gonna have to get over it because this is like 20 years of me improving it. So just imagine what it was like when I first did it. Okay. X squared plus 1 and x squared minus 1. And for some reason, the book doesn't do if, but I like to do if. So there's a lot going on here that I want to talk about. So remember, the alligator eats the bigger number. So this is if x is less than 0, and this is if x is greater than or equal to 0. So that's really important that you identify. It can be with the top or the bottom, but this little bar down here means equal. So that's really important to know that if I do want to plug in 0, I'm going to be picking this equation. So let's try a couple of different ones. So I'm going to have f of -1. Okay, so if I want to do f of -1, that's going to be -1 is less than 0, so I would use this equation, right? So I would go -1 squared plus 1, and then that would be 1 plus 1, which would be 2. Okay, did you guys see how it was less than 0? So I use this equation. Okay. And then if I want to do f of 0, okay, so I have to look because these are both 0, right? Well, right here it says it can equal, so I'm going to use this bottom one. So I'm going to have 0 minus 1, which is just -1. Okay, and then if I wanted to do f of 1, okay, that's greater than 0, so I would use that bottom equation again. So f of 1 equals 0. Okay, so I hope that this is going okay. Are we doing okay, homies? Woo! Almost dropped my teeth. You guys doing okay? We rocking it? Yeah. You guys are you guys this or are you this? The emoji thing is getting out of hand. Sorry, it's a new software. You guys are like on my second class of doing it. All right. So hopefully you are the you're that one. Okay, we're loving it. Is there an in between? No, not that one. That's what about this one? Screaming in terror. There, that one. Okay. We got to get going, guys. Again, normally I won't have this much time. I got to keep an eye on the clock. All right, so, and we're moving forward. Domains. I wish we had more time. We'd have a lot more fun together, you know? I always feel like we're always so business. Okay, so the domain of functions. Okay, remember, this is what values work for the input. Okay. So it's a lot easier. So I'm just going to give you some pointers. Most often, it is easier. Is that how you spell easier? Yeah. Easier to figure out what does not work. Okay, so most often it's easier to figure out what doesn't work than what works. So this isn't always the case. This is just like a general rule, but it's usually easiest if it doesn't work. And for example, in calculus, this isn't not always going to be true. So like if it's a finite answer, this is usually easier. But that's just a tip. Okay, and we'll go through that. Obviously, there's going to be situations where it's not, but most often it is. Okay, when we write domain, okay, we will use interval notation. There's a couple of different notations that you guys can use for domain and range. There is inequalities. So I think that's how you guys first learned how to do it, was using inequalities like x is greater than 2 or x is less than 3, right? So you guys learned that in Algebra 1. I'm sure you did that in Algebra 2. And then there's also something called set notation, where it says x is an element of all reals, or x such that x cannot equal 2. Do you guys want me to show examples of that? Anyways, the reason why I'm just doing interval, okay. Oh shoot, no, element. Here, how about x is, so like there's an example, okay? And then interval just be x is less than 2. And then we're going to learn about interval notation today. Okay? So interval notation would be so those are the three notations saying the same thing. So this one takes too long. This one is too basic. Don't be basic. Wait, is that it? Yeah, don't be basic. Okay, and then this one's just right. All right. You guys like my Goldilocks reference there? Pretty tight, huh? All right. So the reason why I'm going to be focusing on interval notation, it is the quickest, it gives you the most information, and most importantly, it is what is used and preferred in AP Calculus. Okay, so that's why we're going to be doing interval notation. So let's go over really quickly some tools for interval notation. You guys have seen interval notation before? Can you guys tell me a yes or no? You guys have seen interval notation, right? Yeah. Okay. Okay. All right. Thanks, Grace. Apparently your nickname is everyone. All right. Tools for interval notation. So a couple things we need to know. Boom, boom, and boom. All do not include the stated value. Right? So this means less than or greater than. It does not include the value. This right here, the parentheses, it's the same thing as this. It does not include the value. And if you have an open dot, it does not include the value. So if we take a look at this, do you see how x is less than 2? That means x cannot equal 2. So right here, when I write this, that means x cannot equal 2. Okay, is that a good example for everyone? So here, x is less than 2, it cannot equal 2. Here, this right here, a parenthesis, means that x cannot equal 2. Okay? And on a graph, they would use an open circle. Okay? So it might look like this on a number line. So I lied to you. There's set notation, inequality notation, interval notation, and number line notation. Good catch, Craig. All right. All right, so then the other ones would be sorry, I should be talking while I'm writing. So less than or equal to, greater than or equal to, bracket, bracket, and a closed dot. So this means all of these do include the stated value. So from examples of this would be x is greater than or equal to 3. Okay. So that would be the same as, what's the dot used for? I'll show you. So this would be the same as bracket 3 infinity. Infinity will always be a parenthesis because infinity isn't a number, it's a concept. So you can't equal a concept. Okay, so I know that's I spend a whole unit talking about that in calculus, but infinity you can't equal infinity. It's a concept. Okay, and then what would it look like here on a number line? It's closed, so that means it can't equal 3. So Gavin, does that help out? You'll have a homework problem too. So if there's a graph and it has a big old dot, that just means that that value is included. It's the default. So hopefully that helped, Gavin. If not, you can tell me that it didn't help. Yeah, right. That's why I'm doing this, because I expect you guys to have forgotten us some stuff. Okay. All right. Let's do some stuff. You know what I'm saying? Oh, really quickly. Here. So just some really quick things. If I have f of x, because we have some extra time that I'm not going to have in my other class. If you have f of x equals 0, so just really quickly in your head, if I do this and I solve this, what am I finding? Nope, that is not x equals 0. This is the output. So if you answered the x-intercept, you would be correct, right? Because this is the same okay? So just thought you guys would want to know that, okay? If I wanted x equals 0, but you don't even need that. Just go like that. F of 0 would be a y-intercept. Okay? So Graham, what you said about x equals 0, this is x equals 0. Okay? So I'm glad you said that, because that's where we were going for it. Okay? Just really quickly, let's say f of x, sorry, I should be separating this. Let's say f of x equals x squared plus 2, and g of x equals x cubed plus 5. If I go f of x equals g of x, You guys know I can use substitution to set those equal to each other. So that's just a little review. I was going to skip that in my other class, but we have time, so I'm going to do that in. So, Graham, I never heard back from you. Did this help out? Okay, thank you. All right. Cool. So let's get back to domain. Okay, so let's take a look at this. Okay, so again, I'm sorry for the Manicam icon. I'm going to get rid of it. But if we take a look at g of x equals this function, so right away, when we have 1 over something, right, with an input on the bottom, this is a rational function. We're going to be spending next class talking about parent functions. So if you forget these, we're going to do that. But when we're talking about domain, remember how I said sometimes with domain, it's easier to figure out where it breaks than when it doesn't break. So if we take a look at rational functions, does anybody know where rational functions break or why they break? Okay, they break because you can't divide by 0. So we're going to work on this next class, but being able to identify the parent function is like all of pre-calc, and it's basically all of calculus too, because if you know something about the function, you're going to have to include that in your solving. Okay, so you can't divide by 0. So take a look at this, right? I can't divide by 0, but the bottom here, so we have to ask ourselves, what makes the bottom 0? Right? So the easiest way to do that would be like, well, when does x plus 5 equal 0? Okay, do you guys see what I'm doing? So I realized that this was a rational function. I know that I can't divide by 0, so I just need to figure out when is it going to be 0, because I can't include that input. Okay, so I'm going to subtract 5, and I get x equals 5. So what does that mean? When x equals 5, the function does not exist. Okay, so then when I'm going to write my domain, okay, if I'm using interval notation, then I would have to write 2 things. I would have to write from negative infinity to 5. You see how it does not include 5? And then I would have to go from 5 to positive infinity. Oop, that Manicam's getting in the way, that stupid watermark. Oh my god. Yeah, Grace, I totally made a mistake, guys. I'm so focused on teaching you that I don't really care what the value is. Yeah, this is negative 5, isn't it? So, all right, first mistake of the day. You guys got to call me out on that. Sometimes I just get focused on teaching you guys. I lose the value. So let's rewrite that. So it's going to be negative infinity to negative 5 and negative 5 to infinity. So again, it does not include negative 5. Thank you, Grace. Guys, you gotta keep me on my toes. I'm so focused on getting you the concept that sometimes I really just don't care about the value. Because really it doesn't make up because I just made this problem up. Okay? So that's how it would work. If you were using set notation, you would say x such that x cannot equal -5. Now, the reason why I don't do this is because typing this onto WebAssign is really difficult. So we're not going to do this. Does that make sense? So if we were in person, we would do this because sometimes this is quicker, but we're going to learn interval notation because it works all the time. And in AP Calc, I have my students do this because it's faster. Okay? How are we doing for time? Oh, we're doing great for time. Yay. Okay. So this is really important. This example is really important. Every time you have a rational function, you have to check this. Okay, I just want to make that super clear. Lines, there's no issues, right? All domain usually works. Quadratics, all domain works, right? So polynomials don't have an issue with input. Okay, so this is one of the cases that has an issue with input. I just realized I haven't changed up color in a long time. I'm so sorry, guys. I usually use a lot of color. Okay, so rational functions. Rational functions always have an issue. So if you're like taking avid notes, I would put that in the margin. You know what I mean? Like, so if I had really nice, like a nice margin for avid notes, I would be like, hey, rational functions always have an issue with the input. Okay, you always have to check what makes the bottom 0. Okay, because rational functions will always have an asymptote. Okay, I think you guys learned about asymptotes, but I'll get to that when we get there. Okay. All right. There's one more. Oh, good. See, I need you guys. I need you guys. One more. Let's do another one. So here's another example of domain. So let's say I have h of x equals the square root of 4 minus 3x. So this is going to be another example of a parent function that has a domain restriction. And if you remember with the square root, all square roots must be greater than or equal to 0. All square root domain. Okay, the problem is, what if the square root has been, I wrote Ben, has been transformed, right? Because if it's been transformed, then there's more than meets the eye. Yeah. Do I got any transformer homies out there? Yeah. Autobots. Oh, out. All right. What if the square roots has been transformed? So then all we're going to do for this is we need to figure out when this is going to be 0. Okay. So figure out when the inside will be greater than or equal to 0. Okay. So what does that mean? So this means that I'm going to take, let's use a different color here. I'm going to take this, because that's the inside, and I'm going to go 4 minus 3x has to be greater than or equal to 0. And now I'm going to solve this. Now you have to be really careful, and I'm glad I'm doing this example, because remember, something weird comes up when we're dealing with inequalities. So if I subtract 4, And the problem here is going to be with this negative. Whenever you multiply or divide by a negative, you have to flip the sign. So if you multiply or divide by a negative, flip the inequality. I don't know if I spelled that right. I don't care. You get the point. So I'm going to go ahead here and divide by -3, but I got to flip when I do that. So I'm going to get x is less than or equal to 4/3. Because remember, fractions are our friends. It's just when we're like, you know what, I don't really want to do that division. Okay? So how would I write the domain then? The domain for h of x would be, so it has to be less than 4/3. So I would go from -infinity, and it can equal, so it can equal now. So when I go 4/3, I'm going to put a bracket because it can equal 4/3. Oh wow, I got 8 minutes left. Crazy. I'm going to do 1.4 and 1.5 with my third period, so this is going to be crazy. How you guys doing? Let's do a check-in. Are people doing okay? Hopefully, is this review for you guys? Oh, that's good. That's good. So a couple of things. I'm going to do a couple more examples here. But a couple of things I want you guys to remember. So your homework assignment for this assignment is going to be a little bit smaller than normal because you're just doing 1.4. I did open up the first assignment to be done by Saturday. So hopefully you guys got the memo and got your 1.2, 1.3 homework done. If you didn't get your first one, you can get it to Saturday, and then this one will be due by next class. Yeah, we just got to get the interval notation down. So here, why don't we, in the last minute, would you guys want to do a square root or a rational? You can vote in the chat box. Squirt, I love it. That's by the way, if you don't know how to type programming language square root, it is SQRT, square root. So let's do a square root. I'm just going to make one up. Okay, and then I have a really cool feature here, and I'm going to give you guys a minute to do that. Cool. So that was a minute. So I'm going to go over this whether you're ready or not, because that's terrible teaching, by the way. I should make sure everyone's done. But so what are we going to do here? We just have to remember we have to look at the parent function. So it's a square root. So we need to know that domain for square root of x is greater than 0. So then we just have to figure out, see there's a transformation. We just have to figure out now is, okay, so how was it transformed? Because remember, if it's on the inside, right, it's going to be shifting it left to right. So we just need to figure out how much it's shifting it left to right, okay? So I'm going to take, does that make sense, guys, with transformations, right? We just have to figure out where the starting point. So it normally starts at 0, right? Maybe that's a better way of thinking about it, right? So this normally starts at 0, but we need to figure out this transformation. Where did it start? So I kind of put the 4 in to try to throw you off. The 4 doesn't matter. That's a vertical dilation. That doesn't affect where it starts. Okay. So it would affect the no, it wouldn't. Okay, I'm done. So domain. I mean, it would affect the range, but not really. It would just affect how quickly it got there. So the domain, to figure that out, we know that 3x minus 7 has to be greater than or equal to 0. I'm going to go ahead and add 7 to both sides. I get 3x is greater than or equal to 7. I don't have any negatives, so I'm going to go ahead and get now, if I was doing interval notation, if I was doing inequality notation, I would be done. But we're just going to convert this to interval notation, so it can equal. So now this is so it says x is greater than this. So that means this is the lowest it can be. See how that's really confusing? So it always points to the lowest number. So that means I have to begin with it. Okay. So it can equal it, that's the lowest number, and then there is no upper bound, so I do infinity. And remember, infinity always has to be open because you can't equal a concept. It's not a number, it's just a concept. Okay? Which is confusing when you get to calculus because we treat it like a number because it works. Thank Leibniz for that one. Newton tried to do something different, but Leibniz really came through on that one. He made math really easy. It's just like, hey, can we just assume it's a number so we can just do algebra with it? And though Leibniz was wrong, it did make everyone's life a lot easier. Okay, so I only have a couple more minutes. Does anybody have any questions or comments? You're going to have 1.4 homework. You're going to be finding domain, evaluating functions, and that sort of thing, and that's going to be due on Tuesday. And then we're going to do 1.5 on Tuesday. So does anybody have any questions or comments? Make sure you guys are getting your WebAssign homework done. If you're doing that first assignment late, make sure you email me when you're done so I know to update Skyward, or else I won't know to update Skyward. Yeah, make sure I have office hours in the mornings on Monday and Friday, and in the evening on Tuesday and Thursday. You guys don't have any questions? That really amazes me. I can't think of the last time I taught a class where I didn't have questions. I mean, it could just be I'm an amazing teacher, but I'm not buying it. All right, you guys really don't have any questions? This is it's worrisome a little bit.